been talking over the past few weeks, but like we haven't really talked about. So we had Witch Doctor and Hypershock on, and this
Yeah.
this is on YouTube. Did you catch any of that, or have you not seen it?
I don't know that I have. I
It was it was interesting. I think you'll find it interesting. And I have a lot of questions for you about that as well, just BattleBots and even those teams. But it was the first time that we had ever done a SolidWorks Live episode on location. And you
Sure.
picture, beginning of the year, it was a little bit post 3D Experience World, which we didn't have in person. Right? We're going to have in person this upcoming year in 2023 in February. But
It was down in Miami, right?
yeah, it was.
Yeah.
Yeah, so yeah, it was down in Miami. So we were able to go to Witch Doctor and Hypershock shared shop, which was super neat. And we hung out with them at like a local craft brewery.
Oh, very
Grabbed a
cool.
bite there, like a taco truck. And then after that, we went to a live user group meeting in Miami too. So
Oh, nice.
and they were presenting. So yeah, it was like full on just like BattleBots extravaganza. But the reason why I asked you that is because I know, and everyone else will soon know you. you are a part of a BattleBots team, right?
Yeah. And I'm also very new to BattleBots. Like
Okay.
a lot of people come up through like much lighter weight classes and things like that. One of my best friends in the world just asked if I wanted to be on BattleBots to help turn screws a couple of years ago, and the only answer to that is yes. So that was how I joined in. I've got a lot of like SolidWorks domain knowledge, so I'm really able to kind of like help folks get set up with like the maker's offer and help people kind of solve particular design challenges. And it's just been really enormously rewarding. And I'm sad that I had to miss this most recent season, but I'm planning on doing Robo Games, which is coming back next year and has a 250-pound event and BattleBots.
That's what you mentioned about the weight classes. I didn't know that until I spoke to Andrea from Team Witch Doctor about that.
Yeah.
Like she was like, because a question, whenever you do like SolidWorks Live or whenever I've done SolidWorks Live, I've always tried to, of course, like so many people know BattleBots, watch BattleBots, have watched BattleBots for years,
Mhm.
but try to get into the meat of like what got you, like you're saying, like what got you into BattleBots in the first place, and by extension, what sort of advice would you give to someone that's looking to even just generally like get into robotics competitions or something like this, something like BattleBots, where it's I think you said like combat robotics.
Yeah.
So like, which is like a class I didn't know about until I talked to you.
Yeah.
But yeah, she was saying like there are competitions that are much lower weight classes, and I guess there's a lot of merit to that. I'm sure as you go higher in weight, maybe you're going higher in complexity, but also those bots are like super 250 pounds. I mean, that is heavy, and they can be pretty dangerous, like if you don't know what you're doing.
So let's see. I've got a link that I'll pop in with us, and this is just kind of where everything is. I went to a super local event earlier this year that was walking distance from my house. So yeah, I mean that website is a great place to start with. There's a couple of YouTube channels like Maker's Muse recently did some stuff about how to design some of these lighter weight class stuff, and you can get into it with 3D printing and a couple of websites and a soldering iron and some crimps. But that's the
Yeah.
basics.
I see. I'm just looking. Maybe we could put this in this link in the YouTube chat at some point. But I'm just looking and saying, okay, so events in Connecticut, California, North Carolina, Florida. So kind of it looks like domestically all across the U.S. here.
Mm. Yeah, and there's Facebook is one of the bigger platforms for doing this stuff, but you can just show up.
Yeah. Okay. So you can just show up. You don't have to sort of be signed up and like have an established role. Like you can just go. You're saying just to watch or participate.
Yeah, you can just go to watch. Most of the teams that like I didn't really have a role on the last one that I went to. I just went and hung out with friends and made some new ones.
Yeah, no, I mean, we were talking about user groups. This here with the robot combat events that you just shared, it sounds like it's all the same. But hey, we're right on target here as far as
All
time
right.
goes. Everyone,
Excellent.
welcome to SolidWorks Live Design. If you've seen any of our social posts lately, you probably saw this is the 20th episode of SolidWorks Live Design here in 2022, and it is actually the final episode of 2022. It's been a crazy year. We've done a lot of new things with the live design program, particularly. One of the big changes I think that we've done, and I know a lot of you have appreciated that just seeing the viewership numbers, is we've included non-Dassault System team members here on this series. We've had you guys, our power users, our super users coming on to share, your favorite tips, workflow examples, your projects that you've created, all in the spirit of togetherness and learning, right? These are two pillars I think of our community here at SolidWorks, and today is no different. So I have Mike here. Mike, how's it going?
Hi, it's going great in the chilly Chicago area.
Yeah, it's pretty. So I'm looking outside right now. There's a window right in front of me. It's pretty rainy, but at this time of year, and I think you can appreciate this. 45 degrees actually isn't too bad.
Balmy, balmy.
It's a balmy, yeah,
Just
balmy 45 degrees.
just watching the snow inch up over here.
Yeah, we had our first snowfall yesterday. So we have. I think I shared with you. We have two young kids at home, so 2 and 4. So, and I'm sure those of you in the chat, which by the way, we are looking at the chat. So if you have any questions along the way as we get into the content side of things, be sure to ask, and I'll make sure to interrupt here. But yeah, it was the type of snow where it's like your kids are looking out the window. It's coming down. It seems like it should be accumulating, but it's just not really sticking.
Mm-hmm.
I'm at the phase where I'm really excited for the first like substantial
Yeah.
snowfall of the year, just so I can like go outside and actually play with the kids and stuff.
Oh yeah. My all I have here are cats, and they don't quite like the snow as much. So
Yeah, cats. I've
yeah.
had cats growing up. They're not so much a fan, but yeah, I see already some of you in the chat just saying hello and giving rocket emojis, robot emojis. So I think everyone's raring to get started here.
Awesome.
But yeah, so we have a pretty cool episode today. It's interesting. It's our final episode of the year, but it's also one I think heading into the new year. People have New Year's resolutions. They have new skills they want to get to. You and I were talking. What's a good topic to get into? You're a big part of the SolidWorks community in a lot of ways, and one of the things that we kind of settled on through your mixture of experience and passion is back where it all started for a lot of us, and maybe where it will start soon for some of us, right? An intro to 3D CAD fundamentals. So yeah, tell us about what you're looking to get into today, Mike.
Sure. So just for kind of some background, I am a SolidWorks pro. That is my whole job, and we'll talk a little bit more about that later. But my background is not in engineering, mechanical design. I went to school for experimental behavioral economics and philosophy. So just like
We were talking about that. It's definitely it's funny. You are, I think, the second, at least to my knowledge, the second philosophy major in our sort of broad field of design, engineering, and manufacturing that I've talked to. There's actually a member of the team over at Titans of CNC that also was a philosophy major.
Oh, interesting.
So you're not alone, but definitely atypical.
Yeah. So my a lot of what I've done to learn about CAD and SolidWorks and what I'm going to be showing today, 3D Creator, xDesign, that this is all stuff that I primarily picked up just kind of struggling through it or doing research.
Self-taught.
Yeah, I didn't really. I prefer community taught because, someone is making those videos and I'm just accessing them and
That's
not
a good
talking.
point. That's a really good point. I think I'm going to adopt that as well.
Yeah, so it's. I didn't receive any training until I started working as a SolidWorks reseller employee. So I just kind of came in with this knowledge, and it's out there and available for people. And you don't have to have some special cert. You don't need to have any particular background. You don't need to have a special degree. You just need to be willing to sit down and yell at computer.
It's the only requirement to get started, especially these days, right? You mentioned with the maker's offer, which is still very, very new. But for as little as $9.99 a month, right? Price of a streaming service these days, you can get started with especially with the tool that you're about to show today, right?
Yeah, absolutely. So yeah, are you ready to take a look at the whole thing?
All absolutely. Right. And I think, but even before we get started with it, like, one quick comment. These are fundamentals. Actually, the example I know that you're going to get into today, it's one that you've taught in classrooms, one that I've taught in classrooms, but with a different CAD package, right? Entirely. Yeah. So these are truly intro to 3D CAD fundamentals where, if you're looking to get into design, it doesn't mean you can only use this tool, that Mike happens to be using or that Sean happens to be using. We're looking at this to be sort of a holistic experience for everyone, right? You can take lessons from it and apply it to almost any CAD software, whether it's hopefully SOLIDWORks 3D CAD or in this case SOLIDWORks xDesign with 3D Creator. But yeah, a lot of great lessons we're gonna get into today. So I'm excited and I'm ready.
Awesome. Yeah, for me the most important thing is as long as you can get the thing that's in your head into your hands. Yeah, that's just the tops.
So that's what matters.
Yeah. So all right, so I'm just going to go ahead and log into my personal tenant, and that's solidworks.com/makers-cloud. And when you sign up for the offer, just one of the peculiarities of the 3D Experience platform is you get your own tenant, and that one just automatically directs you to your instance. So I believe this is the tab in the dashboard that it shows up for you when you first start up. And I'm just going to go ahead and kind of click over here on this hamburger menu. It's doubled up for me, but we have a couple of dashboards is what these are called. And these are pre-designed sets of where all of your information lives. And you can create your own. These are just the ones that kind of come with everything. And each dashboard can have different tabs, and we can even, add our own. And
yeah. And this is I love how you started here. Again, this is meant to be kind of tool agnostic, right? But at the same time, anytime you go to a new website, a new web portal, a new platform, right? You're kind of unsure of what to click on or where to start. And yeah, I think what you're getting to now is like these dashboard areas aren't for their own sake, right? It's actually they are meant for that very purpose of helping you to kind of navigate your way around, especially if you're new to this tool. And like even like that shortcut you gave to the Maker's Cloud link, like that's a great thing to keep in mind. I always say too, like bookmark it. It's like once you go there, bookmark it, you get back there easy. Yeah. So yeah, these are really good tips to start off with. It's just start feeling more comfortable.
Yeah, and I'm not going to be using it too much here, but I would be remiss if I didn't indicate the giant button next to that little hamburger menu. So the hamburger gets you dashboards. This guy here gets you, this is the compass is what we call, and I just have my favorite apps set up in here. And this is where you can go to install your desktop things. But I'm going to be using xDesign. This is the browser-based, parametric CAD package. And just going to open up a new component. All this.
And this is pretty much like you're just making new component, new file, right? It's like all the same, just something new, file new, right? In this context.
New component, new document, new everything.
Something new that you will eventually, hopefully, hold in your hands.
Yeah. So we're sitting here with xDesign, and it has dropped us into an infinite void. So we're already just like real life in here. One of my favorite things is the chair. This in SolidWorks, it's the reference triad and lives elsewhere. But this gives you your perspective as to where everything is. And over here on the left, over on our design manager, we have our document name. So right up there, we're It says 3D Shape 1, and I'm not going to talk about that today. If you really want to hear about it, we'll talk about it another time.
Sure.
But every CAD package that I have worked with, and it's the number only keeps increasing somehow, despite being a SolidWorks.
Yeah, I think you said to me the other day you've worked with like 5 or 6 different CAD packages. Like,
I think it's slightly more modest than that. I think it's only 4 or 5 3D CAD packages.
Okay.
3D.
All right, so yeah, you're specifying there, but yeah, it's still pretty impressive. It's enough to say, right? Like, to be serious for a second, like that you are worldly in terms of CAD packages. You've used a number of different ones.
Yeah, and the main thing to know is that every CAD package has 3 reference planes built in. And if you think back to maybe some grade school geometry, the XY plane, just get my view normal to that. When people say something is normal, they don't mean like our neighbors or how you're supposed to act. They mean looking straight onto it.
They aren't weird.
Yeah, or abnormal like I am.
Yeah.
So you have your XY plane here, and that's just your Y plane going vertically and your X plane going horizontally. A new one for a lot of folks is maybe the Z plane, and we can see over in our reference triad again, the Z plane goes upwards in space. So X and Y are 2-dimensional and flat. Z is your third axis that gets out. And because you have a third axis, you can now create a plane across those other 2 coordinate systems. So you have your YZ and you have your XZ. And we can tilt and rotate our views and things like that. I have this set up for SolidWorks controls because I love SolidWorks. And you can see as you rotate your view, I'm just using my middle mouse button that it rotates your perspective on your reference chair.
Yeah, it's interesting. Even different CAD packages, right? Like some will use like for example, the X apps here. I see they're using what we call a Z up orientation, right? Mm-hmm. Different CAD packages might have different different sort of directional axes in that way in terms of how they're coordinated in the 3D space. But like you're saying, I think like you said, the void that you kind of get thrown into whenever you open up a new file in a CAD package, right? A lot of times we are by definition we're working on a 2D plane, right? It's at least in terms of our devices, our screens. It's a laptop, it's a tablet. It's a phone in this case, right? You could do that with xDesign, but it's kind of giving you an idea of what it would be like if you were actually in that void. You were across the 2D plane. You're in that 3D space looking around. So these are all good tips, I think, that you're giving to kind of how people orient themselves.
Yeah, and you want to design how things are going to look. Like SolidWorks these days calls them your front, top, and right planes. And you mentioned that Z is up for this, and in SolidWorks, Z actually extends towards you on the screen. It treats X and Y as the sheet of paper, and that made sense in the early days of 3D CAD. Where you're starting with a 2D piece of vellum on your drafting table, and that is your X and your Y in front of you. So Z comes out towards you. So that's why maybe in these days, we think of X and Y just down on our desk or whatever, and our Z coming up towards our face. It's just rotated around a little differently. And, people ask, why is it that way? And, sometimes you make a decision in 1992, and that's how I ended up with a little brother. So that's why we have Y up for SolidWorks. So all of these planes are basically just that I was talking about. These are your sheets of paper that you start with. And all 3 of these planes only intersect at one point, and that is the origin. And if I just multi-click on 2 of these planes, we can see and because these are infinite and just for reference, you can't really zoom in on it. But if you look at it, 2 planes only intersect along an infinite axis. So then when you get 3 planes into the mix, that's just 2 perpendicular axes that all intersect at one point. So that's what we're going to start with. That is your origin. That is 0, 0, 0 if you're using Cartesian coordinate systems in your CAD package, bless you. But and this is just kind of how we start. And before I kind of get into the main bit, I just kind of want to show a quick demo of how all of this links together before we do our big thing.
Sure.
The part that we're doing is usually on the afternoon of our first day of SolidWorks Essentials or the second day of SolidWorks Essentials. So at this point, I've usually just like really beaten people's brains into submission with how 3D CAD works. But I'm just going to right-click one of these planes and click my new sketch icon. And that is pulling my view normal to it. And now my analogy for graph paper is really starting to work out because we can see the grid. And all I'm going to do is just grab my rectangle tool. So let's talk about the action bar, actually. The action bar is where your actions live. Different CAD packages call them different things. SolidWorks is your command manager. And it just has different tabs that different tools live on. And the big two are sketch and features. The workflow goes, you create a sketch that is a cross-section of some feature, and then you turn that sketch into the feature itself. So I'm going to start with this rectangle tool, and that's a corner rectangle. These dots indicate where you're supposed to click. I'll start on my origin, which is indicated by these red arrows, and I get just a little grab. xDesign wants me to, get things connected to the origin because that's the only fixed position in space. Just click once to place one corner, and this is set up such that I can place my dimensions already, but I can just, I can do something weird like this. Then I can come in and put my dimensions on here. I can just click one entity at a time, and your dimensions drive your geometry. And same for something else that we're going to get to later called sketch relations.
Okay.
And so you see that 35 millimeter dimension just kind of yanked that top line out of place. This can be a really unexpected behavior for people who are maybe more attuned to some 2D platforms.
Yeah.
It's
interesting. There's a lot of stuff here that you went over, right? It's like you showed the sort of behavior where the CAD package, and in this case xDesign, but a lot of CAD packages will look to try to get you to anchor to something, right? There is only, in this case, there's one fixed point to anchor to, everything relative to that. But it gives you other cues too, right? Like even the way that it shows the rectangle, it's the only thing that's filled in that sort of, I don't know if it's sometimes I'm bad with colors, but a dark blue or a purplish color, right? It's the only thing that's showing, so that's kind of that's indicating where it's like a closed volume. But even before you did those dimensions, it did have the rectangle did have dimensions in truth, right? It did have a shape. It was it was this long and it was this high, but so just to point out for right as intro to 3D CAD, a lot of beginner users maybe, even if you're just a beginner with xDesign but you've been using CAD for a while, notice the colors, right? They went from blue on a couple of these lines, right? As you add the dimension, it's a blue to black. So what does that sort of signify there?
So this indicates that there is a degree of freedom that our geometry has somehow. It means that xDesign either doesn't know where, how big, or how something relates to something else. And my favorite tool is to click and drag something because it has degrees of freedom. It can float around. So it's okay. We've made a 50 millimeter wide rectangle so far. I deleted this last dimension, and it is anchored in one corner to the origin. So this line down here is what we call in the biz fully defined. That means the biz. And that means that all degrees of freedom are removed from this particular entity.
Okay.
And so if we look at these vertical lines, now we can see that it has a black endpoint where it starts. It's also black, which means that it has definition about this line here, but it ends with a blue endpoint. And if I click and drag this blue line up here, I can shrink or expand this indefinitely. So that means that it has an unrestrained degree of freedom up and down. So if
Gotcha.
I put a dimension along this line or a dimension from this line to this line, then I can restrain that with a measurement. So I'm just
Very
going to
cool.
go ahead and click this line here, and I'll give it my 35 millimeters. And this is a fully defined sketch. All of
Yeah,
my points and lines are black. I cannot click and drag anything.
it's fixed,
Uh,
right? It's kind
yeah,
of all degrees of freedom, like you said, are removed. I see, and there's just so many like little context clues to look at it. It's some of it's just, especially when you're getting started, it's knowing what to look for and which sort of signal is it given to you. But
yeah.
xDesign has some really good ones. I see my good friend Drew Buchanan saying trust the xDesign process. Definitely, I know Drew, a huge xDesign fan. So
Oh,
thanks.
nice. Yeah, and I think that's also a great off ramp, real quick, to show that like I am doing this in xDesign on purpose, and that's
Mhm.
because you don't need a special computer as long as you can get on the web and you can also generate images on a screen of some kind.
Your
You
device
can,
has a battery charge, maybe.
yeah,
Maybe another prereq.
you can use xDesign. I have used xDesign on my extremely weenie Chromebook. I when I clock out, I unplug my work laptop from my dock and I plug my Steam Deck in and I put it into desktop mode instead of gaming mode, and I model in xDesign. I I even have a little prop right here that, let's see if we can get that. I 3D printed this from polycarbonate on a Prusa Mini 3D printer, and this is just an adapter to get my dust extractor hooked up to my miter saw.
Oh,
Like,
cool.
yeah, that was all on xDesign
Nice
on my Steam
utility.
Deck. Yeah, so you don't need a Windows computer like SolidWorks does. You don't need a beefy GPU. You can just you can use what you have and start turning this into something that works for you. So, all right, I think I've covered everything on the sketch, on this first sketch at least. And so there's a couple of icons up here and a similar one down here. And when you start a sketch in a lot of your CAD packages, you are entering a unique design space. You are going from a 3D design space into a 2D design space to get back into your 3D design space. One of the challenges that people most frequently run into in the Essentials class is forgetting to exit their sketch.
Hmm.
Every package I've used that use sketches, you have to exit your sketch, and that's accept sketch, confirm sketch, whatever you call it. Just get out, and now we have our rectangle. And the methodology here for all of these packages is you go sketch, feature, sketch, feature, sketch, feature. You turn your sketches into your features. So I'm going to come over to my features tab, and I'm going to choose this guy right here, this extruded feature. And an extrude is, it works the same way as the Play-Doh extruders. You put your dough in and you push it through the die and it comes out in the same shape all the way through. That's how it works. I have my yellow preview here, and it's showing, where this is going to extrude. We have a lot of super features and things like that I'm going to talk about that are xDesign specific, but all of these have a couple of elements to them. It pre-selected this sketch feature. It calls it Object 1. If I clear that because I clicked somewhere else or something like that, these blue selection boxes indicate that the software is asking me to grab something. So I'm going to grab this profile here. Or I can go ahead and grab the entire sketch out of my design manager. And that'll pull it all out.
Cool. So I'm, I'm
Yeah.
I'm figuring like if you had a sketch like we talked about how the rectangle was filled in all blue, right?
Mhm.
If you had multiple contours or if you had like something that's like thin, which is to say like it wasn't closed, right? And you wanted to select maybe part of it or all of it and give it a thickness value, something like that. These are all different selection criteria that could help you really specify, right, what you'd like to
Mhm.
extrude and how. So that's pretty useful.
Yeah. And something that's worth mentioning too
Hmm.
is Well, let me do this part, and then I'll hop
Sure,
over to
sure.
this. So over here we have this box called direction 1, and this includes our end conditions. And blind for anything in this design software means up like just a certain amount. So it defaults to a 35 millimeter distance for the blind. We can set it to a 50 millimeter blind end condition. We can do whatever. We're going to use a couple of these other ones later on today, but there's midplane, which symmetrically expands about your sketch plane. So if you're making a part that's symmetrical, you don't have to, do it on one side, then do it on the other, or just design half and then mirror it. You can kind of start from the get-go with that. The other one is up to geometry, and we'll be talking about that a little bit later on. But there's also direction 2. So if I were, 50 millimeters up, and I wanted to go, 15 millimeters down, this is asymmetric. I can achieve that just by expanding my direction 2 menu. So
Sure.
I'm just going to turn that off, and we get some other fun stuff that maybe you'll have me back again. Who knows? But I'm just going to.
It's interesting. So you're just getting back to the axes and the coordinates and being in 3D space, right? You're kind of specifying, if you say midplane, then you're going in positive z and negative z, kind of equally. Whereas, like you said, if you go asymmetrically, direction 1, direction 2, right? You're specifying how far into negative z, how far into positive z you're going with the extrusion. So yeah, this is all very useful, depending on what you want to do, right?
Yeah.
So these are core fundamentals.
Yeah, and I started on my XY plane. You can start on any plane you want. You design the way you're going to look at and hold the thing in real life.
Mm-hmm.
So yeah, so this extrusion vector, I suppose, is going in Z because that is normal to perpendicular to my starting plane. If I were on YZ, it would come out along X. So that's I'm getting in the weeds now. But another thing that people miss is that you want to confirm your commands. This is just a preview. I need to hit my green check for this to turn into solid geometry.
Sure.
So we have our first shape, and something that I see a lot of folks do when they're either coming over from a 2D CAD platform or a background where they've seen a lot of drawings, or even just Google image search, like what do blueprints look like? You get these really highly detailed views in these drawings, and people try to capture that on a single sketch. And that's a way to make your life very hard. One of the best things about 3D modeling is that, I have, created a, cuboid here that is bound to these faces and planes rather in the origin. But now I can create a sketch on the face of this. If I just left click there and hit my new sketch in my action bar, this is no longer constrained to my reference planes. This is now constrained to the solid geometry I just made. And I'll just do something fun. I'll offset entities, and I'll click this box here. And we can see that I have a yellow preview giving me an outside offset. If I hit this reverse direction arrow, I can get it on the inside. Just do it 10 millimeters in green check. And now that is referencing this other face geometry to create something new. So you can kind of self-reference your new geometry all the way through. It's very freeing because now I can and will turn this into just a little pocket on the side of this.
Yeah, and you hear a lot. People will call SolidWorks 3D CAD, or they'll call xDesign rules based or parametric design. And I think a lot of the things you've shown, right, whether it's anchoring to the origin point with that beginning sketch, or adding dimensions to where you're saying like this line has to be 35 millimeters, or this line has to be 50 millimeters, or even this where you're doing an offset where you're saying it's 10 millimeters all around, from the sort of bounding edges of the face that I've selected. This is all rules based, to where anything changes, it's like that rule has to be maintained for as long as it's active.
Yeah.
So I think this is a really, really good tip at an introductory level.
Yeah. And just knowing that every time you create geometry, you have something new that you can reference or put something on, it gets very handy. So I'm just going to come over to my features now, and I'm going to click this little expansion arrow on my extrude. We can see that we have my extrude and extrude cut. I'm going to choose extrude cut. But if I look on this menu here, I could have just hit my regular extrude button and just gone over to the cut. So if I hit my extrude and choose this face, let's say we'll just make it 10 millimeters, we can see it go out. But if I change it to a cut, these are super features. These are unique to xDesign among our portfolio. But if I choose cut, xDesign knows to flip the direction of that because I want to remove material. And that's it. I just set my distance and I'll green check. Now we have just a little rectangular pocket. So these are just kind of some foundational understandings that I want to cover before we get into this more advanced part. This is kind of a sink or swim in SolidWorks Essentials.
Yeah.
Where things start to get pretty crazy.
You've already made a nice candy holder.
Yeah.
Just two 3D features. All done.
Yeah. and we'll this is just doofing around. And that also, like, even if I don't have something to design that day, or I don't need to poke at a customer's part that day, every day I fire up SolidWorks or xDesign and I just do a fast extrude to keep just like, I'll spend 2.5 minutes in there, sketch, extrude, and call it for the day. Because it's really important for me to keep that muscle memory. And SolidWorks, especially, if you get the muscle memory and you keep the muscle memory, you get extremely fast at it. So maybe you'll see me at Model Mania World.
I was gonna say there's a spot for you somewhere. Model Mania.
But all right, so I'm just gonna close out of this part. It's gonna ask me to save. I'll hit save. Sure. This didn't end up being a hand wheel. I'll create a new design that's my real hand wheel. So let's see. Now, the platform has a bunch of built-in product lifecycle management, so doing this type of thing
I see you're making great use of it.
Oh yeah, there's someone in Waltham is having a migraine and they don't know why right now. So all right, I'm just going to get started. We're going to start with our fundamentals, and I'm going to pre-select my YZ plane up here. I come to my sketch tab and I'm just going to create a new sketch. So what we've done so far was some very simple geometry, and that was just solid geometry. I am going to start this also with a rectangle. So I'm starting in the same rectangle tool. I'm going to come up to the origin, and I'm already bucking the trends because I'm coming up and to the left. I'm just going to left click and place it there. And if you look at your cursor also, almost all CAD apps that I've used keep you in your tool. It's designed around you doing things in passes. So I'm going to kind of create my rough geometry in a pass. I'm going to add my sketch relations, which we'll talk about shortly, in a pass. I'm going to add my dimensions in a pass. And it can be enormously frustrating for new users who don't expect that. So I hit my escape key in xDesign. I use some other stuff in SolidWorks just to get out of my tool. And the tool next to my rectangle is my arc tool. And there's a lot of different arcs that we can make, but I'm going to create a 3-point arc. And we can see from this icon here how it anticipates you placing the clicks. I'm going to place one for the start point of my arc. I'm going to place another for the end point of my arc. I'll place a third one for the zenith of my arc. I'm going to click that, and just like I can with my solid geometry, I can get my sketch geometry to self-reference. So I'm getting a hint along my cursor with that little circle around it that this geometry is going to be coincident to. It will be on this line that I've placed. I'm going to click once to place it, click down for that other point, and I'm going to left click again out here for that zone. So we can see that we have this big profile here that's colored in, and this guy over here did not get colored in. We're going to use another tool called Power Trim, which is either down here, or I can use something called mouse gestures. And I'm just holding down my right mouse button, and I moved my mouse a little bit. They might be called something else in xDesign, but I'm a SolidWorks guy. And I'm just going to come over to my trimmer extend right here. And now you can see that I have a little pair of scissors next to my cursor. Hold my left click down, and as I pass through a line that intersects something else, it gets rid of that intersection. And yeah, that's the power trim. It's I wish so many other programs had power trim.
So essentially, I mean, it's recognizing with that fill-in now that this is a singular closed contour that can now be extruded, right? It's a closed 2D volume that can be made into a 3D volume of some kind.
Yeah, exactly. And
Gotcha.
In our sketches, we are creating cross sections, and that's exactly what this is going to be. I am going to do something a little weird though, and I'm going to right click. This whole stream's about to get a little weird. I'm just going to right click this vertical line here, and I'm going to use GD it. I'm going to right click. Can't do my little focus ins, but I'm going to hit this top left icon, and that converts my sketch geometry from a solid line to what's called a construction line. You can create your own reference geometry inside of your 3D space or inside of your sketches that you're not really going to be turning into a solid part. And this is going to be important for a couple of reasons that we'll see shortly. The first thing that this has done is it has removed my closed contour. So that's one behavior that's different from solid geometry. And it also has some mechanically interesting elements because this is not going to get extruded like we did with our rectangles in that last part. This is going to get revolved about a central axis. So this is, you can think of it like a pottery wheel or a lathe. If you use lathes, it just brings the same profile all the way around a central axis. So I'm going to come in and I'm going to grab my dimensions here. And because this is going to get revolved about this central line, I can start doing some pretty interesting things with my geometry. So if I left click this vertical line here and I want to dimension it relative to this central line, I've got this dimension here. But because that's a center line, if I bring my cursor past it, this gives me a diametric measurement where I only have to create half of the profile. So you can think of it diametric, radial, diametric, radial. And as someone who's spent a lot of time on a lathe, it just like makes my eyes go crosswise. I've tried saying it enough times in a row. But all I'm going to do is set this to 25 millimeters. And you'll notice that something weird happened. My grid is in a different kind of scale, but because that's the first dimension rather that I put in here, it kept all of my geometry. So now if I put another dimension here, which is going to be 45 millimeters, it scales things.
Ah, cool. So really like, it's interesting. I think people are so worried to mess up sometimes when they start a new piece of software. They're worried, like, if I mess something up, then I won't be able to get back to where I was, or I just don't want to be wrong. So it's kind of, in this case, what seems to be best is just try to make sure that your geometry is proportionally accurate about itself. because the software will kind of do the rest for you with that first dimension, you know?
Yeah, and we'll get even further along in this part. I'll demo some of the weird stuff that I do. Like I
Okay.
even go for exaggeration in my sketches,
Huh.
and then I let my sketch relations and dimensions snap everything into place.
Okay.
So we talked earlier about kind of how when you have your cursor on something that your CAD app is grabby on there.
Mm-hmm.
If you try to sketch too accurately, you can end up accidentally getting relations in there that you don't want, and then you get a lot of yellow and red on your screen, and it just it feels like the software is not cooperating with you for trying to be accurate. And really what the software is trying to do is let me bring the rest of that in for you. I see where you're going. Let me make sure that it's picture perfect for you. So that's kind of the way that I operate, and we'll see that happen soon. So I'm going to grab this upper leg here, and this guy is 10 millimeters long. Okay, so we've got some weird action happening here. I'm going to do a dimension from this endpoint to this endpoint. And we can see that because I have this width figured out, this height figured out, and now this height figured out, I'm going to shrink this down just by adding a dimension, and that will pull it up for me because all of these things are already defined. So just click to click. This guy's only 16 millimeters. We've got that. And now I'm going to grab my vertical here. I'll hold my shift key and click this guy there. Oh, not quite what I wanted. How is it? Okay. There we go. I was able to, okay, so check this out. I'm going to get back into my dimension tool. And when I grab this arc here, where did that even go? That's so fun. I promise you, I practiced my picks and clicks. Is it?
You trying to get like the outside of the arc?
There we go.
Mentioned?
Yeah.
Oh, there you go.
So SolidWorks, the picks and clicks are a little different, and I get on autopilot, but we can see that when you dimension to an arc, it defaults to the center point of the arc, because when you're doing your shop layout, milling, turning, all that, it defaults to the center point of that arc. All I'm going to do is grab this point over here, and that just gives me the distance from this outermost point to this vertical. It'll be 4 millimeters. All right.
Cool.
And that's it for this sketch. We don't have a closed contour. And I'm just going to confirm this. If I come back to my features, and I'm going to hit this revolved feature, it's first asking for a revolve axis, and that'll be this construction line that we did. And the profiles, I'll just kind of click and grab all the way through here. And it thinks for a second, but that is exactly what I want. So I can green check that. And something that that a lot of people, to your point earlier about people worrying about getting things wrong, if I want to adjust a dimension now that I see it solid, I can right-click the sketch, hit Edit Sketch, and I can change any of these. Or I can throw in some sketch fillets here. Change that to 5 millimeters. I'm going to tell it to solve again.
I think it may have been, maybe it's because...
Oh, yeah, because it lost that tangency. That's
yeah,
all right.
there you
Just
go.
have to edit my revolve feature now and grab these two new little sections here. And we're back in. I like to apply fillets for that very reason, but we'll do that later. So, okay, I'm going to start picking up the pace a little bit. I'm going to create another sketch on my YZ plane. And this time, I'm going to start off with a line here. And that V for vertical gets applied to it. I'm going to convert this into an infinite construction line. That is vertical here. I'm going to come over to my straight slot tool in my sketch. And I click once for one center point, click again for the other center point, and then click a third time for the thickness there. And I'm just going to go on a dimensioning pass. I'm going to relate this center line to the top of that solid geometry, so you can reference solid geometry inside of your sketches. 6 millimeters there. Center point of this slot, we're going to once again do our radial diametric trick for 170 millimeters. Again, I'm going to grab my thickness here, and this is going to be, here we are. Whoop. Endpoint to endpoint. Grab that.
That's such a cool feature. I mean, essentially, it's just allowing you to change whether you're going to the min, max, center.
Yeah, and cool. That's really nice, especially for touch devices too, that you can just kind of click your dimension and get back in there to relate things. And now, instead of getting one thick closed body here from a revolve feature, I'm going to bring this all the way around. So I can green check, come over to features, one more revolve. Choose your axis, choose your profile, 360 degrees. We're good to go.
Cool. It's starting to look like the thumbnail of the episode.
Yeah. Now we just got to get something from over here to over there, which is achievable. I'm going to create yet another sketch on my YZ plane. And over in my design manager, I'm going to right-click these sketches to get them to show, because I want to relate to some of the geometry we have in here. And I'm just going to pop into my line tool, and I'm going to start this from this center line here that's showing up from my two sketches that I've done earlier. I'm going to come out horizontal. What I'm going to do is go out and come back in, and I'm going to create something called a tangent arc. That means that I'm creating an arc that is tangent to the line that started it. And it drops me back into my line tool. And I'm going to do yet another tangent arc. Then I'm going to go horizontally out from there. So I mentioned sketch relations driving our geometry, and this is the part where that really comes in. And I'm just going to kind of move this out of the way to show what's happening here. If I come to my View tab and hit my Hide Show and just hit my Sketch Relations icon, we can see that xDesign is implicitly adding a lot of relations.
Oh, there you go.
And This is my horizontal, tangent, 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 horizontal. And now what I want to do is do things like get this endpoint coincident to this midpoint and this center point coincident to this line, and then get a few dimensions on there. I like to do relations before I do my dimensions because things start to get a little wibbly. And if you click any of these relations, it highlights the entities that have that relation. So these two arcs are tangent. If they weren't, I could add that relation. But all I'm going to do is left click one arc. I'm going to hold my control key and left click the other, release my control key, and we can see all of our different relations that we can add. So we have tangent, concentric, equal, co-radial, fixed, or added dimension. Set these to equal.
Nice. That was one of the questions in the chat. And there are a number of ways how you might want to link dimensions and where you might want to do it. But that's certainly one way, right? If you're going, of course, you'll dimension these soon. But yeah, you're essentially establishing through a relation, not a dimension in this case, that these two arcs should be of equal value. So that's very, very cool. So that answers that question there.
And we've also triggered one of my sleeper cell SolidWorks feature information things. There is a feature in SolidWorks called link dimensions. In virtually every case that you would use that, I would recommend using either an equal relation or a parameter, a global variable. It's just more usable and easier to edit later on. But yeah, I'm just going to click this endpoint here, and I'm going to control click this midpoint here. Use I forget that it runs away from me when I try to do my spotlight on there. I'm going to hit my coincident. All right, and that shifted a bunch of my geometry. We can kind of see how things are starting to look over here, how my degrees of freedom are getting limited.
Sure.
And I'm just going to grab this center point here and this line segment here and make those coincident. That center point was from our very first sketch, sketch 1, that made that hub section. And now I'm just going to throw in my dimensions. I can come to my sketch tab and hit my dimension tool, or I can use my D key for dimension. And I'm just going to grab one of these. I'm going to make you a 29 millimeter radius. Okay. Something that can be easy to lose track of is what is a leader and what is not. So it did some weird stuff, and it looked like it kicked stuff kind of all over the place. Be calm.
Be calm. Yeah, it's okay.
And I'm just going to grab from that center point to the start of those arc segments, and I'm going to set this to 55 millimeters.
Yeah, and
that's
just as you, before we move on from this section, I really like some of the things that you showed. You know, one of the things that I really wanted to call out from the method that you chose to take with this handwheel design is that you're showing 2 previous profile sketches for your revolves, right? And that's how you're getting, if they look familiar, it's because they are, right? We saw them sketched, and you know, they aren't the active sketch, right? They aren't editable, but they are referenceable, which I think is an important distinction. And that's how you're able to get those centers of those 2 regions. So I thought that was a nice utility. And then that last dimension you added, the 55 dimension, we can kind of see that, you know, there are different senses of a dimension, right? Between 2 points, right? You can get this horizontal dimension. It could be an angle, right? The sort of, you know, sort of straight normal dimension.
Yeah, that's great. I'll get back into that. So we have our linear dimension here, just straight line to line. If I come out to the left, I can get a vertical dimension. And you can see that it goes to a lighter gray. That may be hard to come through, but that's because that is a driven dimension. The dimensions for, you know, that endpoint and the, you know, kind of the top and bottom horizontal sections are determined by other sketches already. Or if I come up, I can get my horizontal dimension. Yeah, that's a great call out. And this sketch here is what loses the majority of my students. And I swear it's not because I'm a really bad AE. It's because these can be easy to hear and hard to see, especially when you're following along click for click. And I really like that this is just going to be here forever, because the majority of our viewers are probably not trying to follow click for click like you do in a classroom. You can come back and create this on your own time, anytime, with our dulcet tones guiding the way. So I'm going to confirm this sketch, and this sketch is also weird for another reason, and it's because we're not going to turn this into solid geometry yet. We're going to combine this with another sketch. But one of the powerful things about linking this to the existing sketch geometry is if I come back and, for instance, edit sketch, let's not do sketch 1, let's edit sketch 2. If I say, oh, this 170 millimeters is actually not great, I'm going to make this 185. I green check that. Look at that. The sketch that we just did still follows through to the established center point. And that is something that SOLIDWORKS XDesign do really well, that a lot of other 3D CAD applications are, I'll generously say, are somewhat less gifted with. But with those done and those references established, I'm just going to right-click these sketches, and I'm going to hide those. I'll leave this guy here. Something to note as well is that you can rename your features, which is great, because Revolve 1, Revolve 2, and all that are not very handy, especially if somebody else needs to see it. If I left-click Revolve 1, press F2, I can name this Hub. I can name this Rim. And that'll stick through. That'll stay when I save, like I do right now. And you can just view that anytime. It makes edits in the future later. I'll open files that I was working with last week and be like, what ding dong was doing this?
Yeah,
terrible.
I was going to say, it's good for someone else that might be editing your files, and that someone else might be you in 2 weeks.
Yes, me, I'm the ding dong. But okay, so we've been doing all of our sketches so far on this YZ plane, but we're going to come around to our ZX plane. I've lived in the States my whole life, and for whatever reason, in CAD and design, it's always like my Z axis. So if that slips,
say it differently. I've noticed that too.
If that slips, I'm not really sorry, but there's at least an explainer to
explanation.
Yeah, another one of my abnormalities, I guess. So I've left this last sketch that we did showing, and now I'm creating a sketch on my ZX plane, and I'm going to create an ellipse, and that's this tool here. An ellipse is kind of like a circle, but if it were Looney Tunes, if you could squash it. So I click once for my center point, and you can see that it's starting to do some fun stuff for me. I'm going to be careful and make sure that I keep that H coming along my line for my horizontal. So I click my thicker axis, the major axis, and then I click again for my minor axis. And this is looking a little cluttery, so I'm going to come back to my view and just turn off my sketch relations again and just trust in the xDesign process. And so this is what I talked about with kind of being caricatured, because I'm going to center this profile I'm drawing here on this line, but in order to avoid accidentally, clicking or referencing this edge or something that I don't want to, like SolidWorks will default to this endpoint instead of or xDesign rather will default to the endpoint instead of the line. I'm doing this off to the side, and I'm just going to get back normal, and I'll hit my dimension tool, and I can use these horizontal construction lines. SolidWorks 2023 Service Pack 1, I think, is getting construction lines in your ellipses, so bless. That's going to save me infinite clicks on all of my future Essentials classes. And this is just 14 millimeters wide by 12 millimeters tall. And that's it. So all right. So our sketch is underdefined. Our geometry is determined, though. I can't twist this, but I can place this. And I have a center point on this particular piece of geometry. I'm just going to use my middle mouse button to rotate my view very slightly, because I'm going to add a relation between the horizontal section of the line from our last sketch and the center point here. Click the center point, Control, left click that line. We've got this guy here, Make Pierce. When I hit this button, Pierce Brosnan is going to appear on my screen. This is
coming in a future service pack.
Yeah. Service Pack 6, the legendary. The Make Pierce relation, as you saw, is a lot like coincident. So if I put a coincident relation here, it also locates that contour. For this particular feature that I'm designing for, though, I need to use this Pierce relation for reasons that are out of scope for introductory CAD. But what I'm going to do is use this profile that we've just made and this path for a sweep feature, and this path to create a solid sweep feature. So I'm just going to green check out of my sketch. I'm going to hit my sweep here. And the sweep, once you see these options, is kind of intuitive. It needs a path, and then it needs a profile. If I were creating train tracks, I would just create the cross section for the track, and then I would create a one or two sketches that are just the entire circuit of that. So my path is going to be this path here, and it grabbed onto the rest of it. Oh, it didn't grab onto the rest of it. I'll just grab sketch 3 to save myself some future. We're going to be like that today.
I highlighted it differently.
All right. I can click 4 times. I'll live somehow. And then for profile, so I select all of this from one sketch, and I'm going to select the profile from this other sketch, and we can see my preview and how that's bringing things along. I'm going to leave all of my options at default. If you want to hear me talk about the more advanced sweep options, you can sign up for an advanced part modeling class, or you can find me on the street, because I will talk to you about CAD.
So this is interesting. So you went from having, it's very visibly two bodies, two pieces of material that were disjointed. They were not together.
Yeah.
And now, right, it looks like through that sweep feature you just did, you've basically joined them into what looks like one complete, almost fully assembled hand wheel, right?
Yeah, we're getting there. And I don't know what this guy is called in xDesign, but I know that's my rollback bar in SolidWorks. And you can actually use this if you're just like, oh, I actually wanted to do something before this and edit something. You can click and drag this up to wherever you want to make those edits, and then you can drop it back down, and now things are stacked up. It's kind of like your design time machine. If you wanted to do something before this, well, I can do that. I can just bring it up. It's kind of and that is a direct differentiation between this type of CAD, parametric solid modeling CAD, versus sculptural stuff. So that's going to be like Blender is a very common option. Even in X shape, it can get a little hairy undoing getting back in your design history. So that's just a really important differentiation. It's because, when you create your first prototype, it's just like, oh, geez, well, you don't have to create the whole part now. You can just kind of go back and edit and inject things where you need them to go.
Sure. And I just wanted to mention, just for the stream's sake, Mike, just wanted to thank you all for jumping on here. I know, Mike, you have just having talked to you before the stream, you have a couple other things to get to, which
we're very near the finish line.
Yeah, but we're getting some really cool stuff here, and even some things that are maybe more xDesign particular, which I think again, you have some neat things to show. But just wanted to acknowledge the audience here, you guys. Thank you so much for jumping on. Just like the SolidWorks account in the chat said, and like I mentioned earlier, this is the 20th episode of the year. We'll certainly be doing more of live design next year. Be sure to subscribe, like this if you've liked Mike's demonstration here. But again, thank you so much for sticking with us here. And I know Mike has some more cool stuff to share.
Yeah. We talked earlier about it kind of being funny that the last stream of the year is kind of about these very basics, these fundamentals. And the month January, named after the Roman god Janus. He has two faces on his head, one looking forward, one looking back. So it's always looking at and that's why it's the first month of the year. So it's a new start and closing up the past.
Very cool.
Yeah. So, all right. So we've got a bunch of our stuff done. If I were to actually hold this in my hand, it would be very flimsy. Yeah. It would break nearly instantly. So if I'm going to create more support structures, and instead of doing two kind of gronky sketches and doing another sweep, I'm going to create a circular pattern. So right here we have our linear pattern. If we open it up, we can see our circular pattern. Some packages call this like a polar array, which I think is a very cool science fiction-y name. I'll put in an SPR for that to be renamed from circular pattern to polar array, because it's. But so all right, so it's asking for features to pattern, and as a toggle here for bodies, let's talk about that real quick. A feature is any of the things in here. These are parametric feature-based modelers. So our geometry is kind of secondary in the hierarchy to the features that are being used to create it. If we chose a body, if we tacked this body selection, that is an enclosed volume. So that is this whole body. If I clear that and select a feature like this rim, or what we're actually going to be doing, this sweep that we did, it's just getting that part. So that's something worth keeping in mind, that your features are categorically different from your geometry, but they are related. And all I'm going to do is drop this down to 3 instances. The number of instances in xDesign and SolidWorks patterning includes the original. And my pattern axis is going to be about the center. And here we go. My instance angle is going to, so this is giving me 3 instances 90 degrees apart from each other. I'm going to do pattern angle at 360 degrees apart. So, or 360 degrees total, subdivided evenly by 3. We can kind of arbitrarily increase the number. Like 7 spokes across 360 degrees is hard for you and me to do, and we need a dividing head in the shop
Right.
to do it. But for xDesign and SolidWorks, that's a non-issue. So 3 instances at 360 degrees, and I can green check that. And now we've got something reasonably close to our finished product.
Yeah, and it's cool to see as well, like all of the spokes you have here, they all sort of have that same quality at their beginnings and ends where they have a bit of overhang, right? That's one thing that comes up in CAD a lot, right? It's like sort of how do I make sure that it merges properly and that we don't have this sort of weird, ugly little people call like a knife face or sliver face that's just sort of hanging out there, doesn't completely end. And that was one of the reasons, right, where other than having those center points there, that the way that you made the profile for the sweep really came in handy, right? Because it ensured that it would go fully like into the material of the sort of handle portion and the hub portion, respectively.
Yeah, I've got a manufacturing specialty as a SolidWorks application engineer. So I already work with people doing CAM frequently on parts that they're getting from their customers who are using, Lord knows what. And just like I'll happily do another live design session on fixing files people send you, because again,
it's a huge topic. Yeah.
Yeah, I started with surface modeling with Rhino 3D, and that very well prepared me for editing models, because it's just like, okay, non-manifold faces is not something that is in like regular SolidWorks AE vocabulary. It's just not a problem anymore. But this guy here. Okay, so we have our spoke patterns, and I'm going to take a moment to talk about controls too, because when I first started doing CAD, it was really hard to keep track of where I was in space. So I would oftentimes like do things that would like do this, like I'm way out in space, totally lost everything. How do I get back somewhere I can look at? My F as in Foxtrot key will zoom to fit, and that's true in both SolidWorks and xDesign. So now I'm looking at this with some orientation. It's the spacebar in SolidWorks, but the G key in xDesign to now choose a face to grab your view selector. And for a lot of folks, working with the just free orbits is challenging and not intuitive, and it does take like some real work to get the hang of it. Just like it's like learning a brand new video game.
Sure.
So you press your G key, and now you can just choose the view that you want to work on. Or if I'm looking at a part and I want to be normal to that particular face, that's not going to be on one of the views. I can right-click a view and hit this icon here, my normal to, and that'll bring me right to it. So those are handy controls, and so yeah, you don't really even need a mouse to do this. I'm using a stylus on my Chromebook when I'm designing there, or on a tablet. So if you're stuck with a trackpad, you can still work with xDesign. It's really not going to leave you hanging on that front. So, all right, we've done that fun stuff, and we're nearing up to finishing touches. I have a handful of fillets that I'm going to put in here. So let's see, I'm going to grab my fillet tool. We've talked about how your workflow is sketch, feature, sketch, feature, sketch, feature. That is true for sketched features. The circular pattern fillets, another one called shell, things like that. These are applied features. You're still inputting parameters, but they are you don't need a sketch to do them, more or less. So I have my fillet dialog box shown up here. I'm going to grab this edge here, and it's giving me 0.85 millimeters. That's not quite what I want. I'm going to grab 3 millimeters. There we go. And we can see kind of how fillets work. And I could even grab this gumball here to kind of arbitrarily click and expand to kind of, one of my favorite games is to see how big of a fillet can I generate
you
here.
don't get the preview goes away.
Yeah, we can almost get an inch on this, but
yeah, and it's cool too that like the way that the edge was created in 3D, right? It sort of splits it down the middle. But since you have tangent propagation checked by default, right, it kind of knows to go along the other side of that.
Yeah, nope. That way madness lies. I'll get too far into the weeds if I start talking about split cylindrical faces. I'm going to clear this option out here though, and here we go. In xDesign and SolidWorks, we get some selection managers. This is design assistance for selection here. I'm going to click that, and we're going to see what this guy gives me. We've got a couple of suggestions involved here, and here we go. We can see the faces that it's giving me. So it's giving me some of those. It's not giving me the ones that I'm looking for. You can fool around with these, and we can select that and add those.
But the idea though, right? It's like you went in there with the motive of trying to speed up your processes. And I guess if I'm watching this, I might be thinking, okay, well there are 3, and it's easy enough to rotate, but sometimes there are far more than 3.
Yeah.
So if the system, right, can automate, and you don't have to go with its selection, right, if you don't like it or if it isn't exactly according to your intent. But a lot of times, even if it doesn't get each one, right, it may speed up your process, and then maybe you have to get 1 or 2 extra ones.
Yeah.
At least saved you maybe 15, 20 clicks. So it's a good thing to be aware of, and it's right next to your cursor.
Yeah, especially when you're designing for things like additive manufacturing and casting, and there's a lot of fillets that you have to start applying.
Yeah,
things get weird. The logic behind the way that xDesign does it and SolidWorks does it are a little different. In SolidWorks, you click one and then you go to another. But if I click that guy, and then I click this one here, and then hit my suggestions, it's usually starts pulling in even more options. Let's see what all. It's not grabbing them here. Who said machines should learn? All right, we've got our clicks in here, and that's going to have them all applied in there.
Cool.
So we have our fillets applied. And last, we're going to apply a chamfer. A chamfer serves a lot of the same purposes as fillets for those of you who are new to things. A fillet is a rounded corner. A chamfer is just like a clean edge break. And so they're by the same icon down here. Choose chamfer. Also, if you come up here and use your drop down, you can go back and forth between fillet and chamfer.
Oh, cool.
Yeah, and we have a lot of different kinds. The default is a 45-degree chamfer angle because that's really easy to set up in a machine shop. But we can also do distance. If once again you remember your grade school slope calculations, y equals mx plus b, it's programmed deep inside. You have your rise divided by your run. Your run is your x-axis, your rise is your y-axis. So my run here is going to be 4 millimeters. And my rise is going to be 2 millimeters. I'm going to apply it to this face here, and we can see how that applies. So if it were symmetrical 2 millimeters, it would look like that, but we're going to do it a little off-center, give it a slope. And there we go.
Cool.
We have our fillet there, or our chamfer there, rather. And
nice.
Yeah, how are we doing on time? Because I can just save this and hop over to the one that I sent you earlier that I ran those results on.
We're about 16 minutes over an hour. I mean, but I think with the scope of the course, and I think overall the helpfulness, especially long term, whether you're getting into xDesign or, again, like you've mentioned several times, Mike, if it's your first time getting into parametric sketch based 3D CAD,
Yeah.
even if it's an hour and a half, right? I think that's a great use of an hour and a half. So
Great.
for sure.
Because this is where it starts to get really nice. If these hand wheels frequently need extra leverage, how could I ever get a cheater bar onto this wheel if it gets really stuck? So I'm going to create a sketch on this tiny flat face that we created with our rim. I'm going to right click and hit my new sketch button, and it draws me in normal to it. I hit my C button for my circle. I can come down here for it, but I'm just going to place the endpoint of this circle. So let's actually, I'm going to do a line. I'm going to do a construction line first, so I can be really fancy. And I'm going to do it from one edge there, get out of the way, horizontally, there we go, to this other edge next to it. I'm going to right click, turn that into construction geometry, and I'm going to constrain this horizontally to my origin for what I assure you are very good reasons. Sometimes coincidence acts a little funny. Great. Coincidence acted funny in the way that I needed it to. Coincidence is like two things touching.
Yeah.
But it can also be two things touching, like sharing an axis or sharing a face.
It's right. It's kind of getting back to what how you can see a line. What is the definition of a line? They would intersect if the line continued, right? So it's a good thing to bring up, and I also really like what you're doing. Just zooming out a little bit, with a lot of times you will look for in a CAD package, right? I'm sure you'd agree. You'll look for different references. If you hover over a certain entity at a certain point, maybe you're looking for a midpoint of an entity to suddenly appear. But if you don't get it, right, a lot of times, or maybe this is preferential, right? You could just kind of make your own construction geometry, and then go from there. I think that's a great tip.
Yeah, I'm very big on making my own construction geometry.
Yeah, me too.
Obviously, whenever I touch a customer's part, if you use more construction geometry than I do, you're impairing yourself. Or if you don't use as much as I do, you're clearly unsophisticated. It's the only the amount that I do is right. But construction geometry is so useful because sometimes if the powers that we can make these edits up our design manager or feature manager tree, whatever. Sometimes if you make a big enough change, it can lose those things. And that's just kind of about how SolidWorks keeps track of where everything is, or xDesign keeps track of where everything is. So frequently adding construction geometry can make errors or warnings that show up later a little bit easier to manage, because you have like 1 degree less abstraction of what you've got and what you're trying to fix. All right, so we have our center line here. I'm going to go ahead and create a center diameter circle. And because this is a really tiny line, I tell my essential students all the time that I use SolidWorks like a grandma because I'm like zoomed way in there. And especially on small stuff like this, I'm going to hover over this line, and we can see on my cursor feedback that I have a circle around it now for coincident. But as I get towards the middle, that'll transform into a triangle. And that triangle in xDesign means that it is the midpoint.
Okay.
SolidWorks behaves a little bit differently. It shows you an explicit point. xDesign, you got to kind of uncover it. But once you've got it, I can click there. And now with this dimension showing, I'll just type 20 millimeters. And my sketch is fully constrained. I can confirm my sketch. So I want to extrude this up, but if we take a look at our sketch here, we can see that it overhangs the circular edges of this rim.
Mm-hmm.
So I don't just need to extrude this up, I need to extrude this down as well. So I'm going to come back to our extrude. I'm going to grab this profile here. let's see, this guy comes up, how far do you come up? 6 millimeters. But then on the downside, I'm going to do something different. So we're going up 6 millimeters, and then in direction 2, I'm instead going to use up to geometry, or actually I'll use up to next. And you'll see that it's going all the way through this body here. And that means that since this is set as up to next, no matter what changes I make, because this sketch is constrained to the center of that rim, if I have to make it wider, the sketch will follow. If I have to make this rim taller, so too will this end condition follow as well. And that just ensures that I don't get any of those tiny slivers or, slivers, they're so bad. But
sure.
There we go.
It stays right. You're saying it. You're basically future proofing it so that if the shapes change in any way,
yeah,
it still works, right? You still have enough overhang to merge the extrusions together.
Yeah, and this is about maintaining design intent, which is such a hard concept to convey, because for this knob, there's a lot of ways that I can place that in space. I could, place the center point of that 85 millimeters away from the origin, and that would happen to be on top of my rim there, but it wouldn't follow any of the edits. What's important is that this knob is on top of the rim, period. So it has to relate to that rim. And that just, once you get it, you've got it. And it's hard, and you can kind of hint at like different little things here and there. But
well, it's kind of one, if you abstract it away from CAD, it's just setting the proper rules, right? So for example, one thing that most of us would find natural, I hope, is if you were to say, you have your pick up your kid from school at 2:00, right? Versus pick up your kid from school when school is over.
Yeah,
those are two different things. So let's say school lets out at 12 that day, right? If you were only set on picking them up at 2:00, well, what do you think is going to happen? You're
you've
2
got a
hours
club
late
kiddo.
to pick up that day, right? So it's just design intent is that way, right? Because things can change, right? Conditions can change. So what you should say in the previous example with picking the kid up from school is pick them up from school when school is over, right? That is the proper way to do it, to ensure that your kid is never staying 2 hours late waiting for their pickup and you've kind of missed the boat on it. So no, I think it's the geometric example of that. I think it's a really good point.
That's a great way to explain it, and I'm going to take that into class because I don't have kids. I never that was not going to come up for me.
Never going to come up.
Yeah, but that's great. All right, so I'm going to get in a couple more edge breaks. This whole thing is eventually going to be cast out of material, so fillets are important. And I sabotage myself because F is fillet and a lot of stuff, but it's just zoom to fit and everything else. And entities is a funny word here, and it's doing a lot of thinking for me. I just changed my radius to 1 millimeter. I can choose an edge to be filleted, and it goes all the way around, or I can choose an entire face to fillet, and that will fillet every edge on that face, and that can save you a lot of clicks. I did not do that earlier because I didn't want xDesign to try and add in a fillet there. All right, we've got our final two elements here. I'm just going to create one more sketch on this part to make a hole so you can actually attach stuff. Let's see, and this is going to be a 9 millimeter hole. So I'll hit my C key, and if I hover on a circular edge, you can see that it has woken up my circle center point. So boom, we're fully defined in there. I can green check, and I'm going to press S for shortcut, hit cut, and I'll grab that profile. And because the important thing is that it goes all the way through, I'm just going to set my end condition to through all one way. And that just makes it go through the entire bounding box of your part. So be careful when you want to use.
Be careful. That's a good piece of advice, right? There's nothing underneath in this case, but if there was.
Yeah. And the last thing I'm going to do is create another sketch down here so we can actually get the part on something.
Cool.
And I'm going to create a circle. And tragically, I prefer to design in millimeters. We could change that anytime over here, but that changes for the whole document. If you, like me, also design in metric, because I don't need drill sizes with letters on them, I can mix and match my units. This is going to mount to a 1/2-inch shaft with a D hole or with a D grind on it. So I'm going to set this to 0.5 IN. That gives me 12.7 millimeters.
Oh, that's a good tip. It does the conversion for you for that dimension.
Oh, yeah. And if anyone ever gives you guff, imperial is based off of metric. We didn't know how big an inch was until World War II. So, so all right. I put another line inside of here to give me my D size, or my D geometry. And if I just left click that, I can make that vertical, which is what I want. And I'll also throw a dimension on there. And this is good. This is some inch to metric conversion that I couldn't find. 7.3975. I wasn't invested enough to find it. Then I'm going to get back into my power trim, come through there, and I'm just going to confirm my sketch. I'll do another extrude. Using super features, I can make it a cut again, and it gets cut into a 1/2-inch depth. So I can just type once again, 0.5 IN, and it's in there.
Awesome.
And that's it. That's the part. That's our hand wheel.
There we go.
So the other thing that I wanted to show is something called design guidance, and
nice.
It's a little time consuming because it takes a lot of electrons and silicon and such to do. But through the power of movie magic, I already made this part earlier in my Sims. And I just want to talk about this.
Sure.
A lot of times, this is strictly part of a subset of our, computer-aided engineering called simulation. And I'm a machinist at heart. I don't run a lot of simulations. When in doubt, make it stout. Like that's my guiding principle. But simulations can do some really cool stuff, and that specifically is design validation. SolidWorks Premium comes with Simulation Express, which you can do, and that'll spit out like factor of safety and things like that. But if you just kind of want to see how all of this works, you can pull in your SolidWorks geometry into xDesign to run this design guidance. And the way it works, let's see. The way it works is that you choose a force, and you can choose a force or a pressure. A force is just like a whap. A pressure is everywhere all at once. And then you choose a fixture, something that is not moving relative to the force, that would move in line with the force or is attached to another system or is where your rivets go, what have you. You can make a design guidance study. And I set this to a redesign to make sure that this can stand up to the particular loads. Mm-hmm. I applied a specific material to it. This is a casting material that I don't know too much about, and there's a lot of stuff in there. To get all of these faces, I just did a box select. I just click and dragged my mouse over the whole geometry because
important tip.
Yeah. And we get a lot of info in here. Symmetry is a big one because you can say, hey, my part is symmetric, about this plane. So only compute, whether or not it can manage the force that we set up here. It's going to look the same on both sides. Mm-hmm. And then we can get some info. you can export these results and you can, do a lot of things like that. But what I want to I was afraid for a moment that it was going to start going. If I hide my geometry by hiding the final feature, and I come on, buddy, you're not. Okay, you should be showing. Why it's not? Maybe it could be a Zoom thing or a Skype thing rather. But we can see that it has given me this very large mesh.
Mm-hmm.
And let's see, maybe that's a display option. Here we go, results display. I'm not going to do that. That sounds computationally expensive. But what this lets you do is if I just multi-click,
mm-hmm.
when it spits out this mesh that it gives you, one, you can 3D print it directly if you want, which is cool because that looks super rad.
Yeah.
But two, if your design guidance gives you a mesh larger than the part you have designed, you need to build a thicker part. You can see the simulation grow the geometry rather as it goes along. You have to tell if it gives you something bigger than that for your estimated force, make it thicker. If it means that if it gives you something that is thinner than your geometry, that means you can take stuff away. So like, for instance, on these spoke rims, I could peel away some of this if I wanted to, but that means that I would have to redesign my seed feature up over here. And I can't get away with that there. So
you mentioned design guidance, right? We're at an hour and a half. This was intro to 3D CAD, right? You've shown a lot of really good tips in that point and to that extent. But like you said at the very beginning, to take us back there, it's you want to make sure that what you're building can actually work for the conditions that it's likely to be faced with in the real world. And looking at your mesh, right? And I don't think you mentioned this, but you essentially you're putting, where did you put the force?
So the force is on this little hole here.
Okay.
And the fixture is this D hole here.
And it stands to reason, right? It takes, like you mentioned, you can add symmetry conditions, so you're basically specifying computationally, right, that you can only worry about maybe half of this, so it can take less time to give you the results and the resultant mesh from your study. But it makes sense, right? If you just show the resultant mesh again, that it is a lot beefier in the area much closer to that cylindrical face, right? Because if the force is being applied directly there, then you're going to need more material there so that it's not breaking, giving the properties of the material and the geometry. But this is a really, really good tool, right? A lot of times you think about CAD, it's like, okay, well, I'm making 3D shapes, but to have it right there in a tab, and again, to run there are videos on YouTube where you can show like sample studies, more pick and click type stuff for design guidance, but just the awareness that it's there, and once you have your sort of idea of what the shape is, what the part might be, to be able to run that study from within a tab in the same app is very valuable.
And this falls into a domain called generative design. And it's cutting it. I've actually got a part that I did design with generative design. This is
nice,
fun and funny. This was 3D printed on an SLS 3D printer. It's
cool.
A selective laser sintering printer. And I did a lot of light weighting, and this just captures cards that come out of an ID card printer. There was a supply shortage, and we had a machine locally. It was just like, okay, how do we minimize the amount of material that we need? And it spit out a mesh like this, and I just kind of, everywhere that there wasn't a mesh, I knew I could put holes in there.
Yeah.
To lightweight it. I had some extra stuff like these fins that may be a little hard to see, so the cards wouldn't slide out the side, but it's a really useful technology, especially in the context of 3D printing, additive manufacturing. And it's just so cool, the tools that are available now.
Yeah.
It's
like it's changed, I would say, even in the past like 5, 10, 15 years. Just remarkably so.
I had to run the simulations in a commercial license. Cost a lot of money, and that was just 4 years ago. So
yeah.
It's very cool to have those capabilities at home, and you can build your portfolio and your resume and just have a good time. Just do the
Yeah.
fun stuff at home. Hook up your dust collector so you can do carpentry, which is not 3D CAD related at all. Yeah, I'm just so thrilled, and I'm really glad that I could show how to get in here from just even navigating to the page, logging in, and just going to town.
Yeah, and I can say for sure already that a lot of people that are using xDesign, using the Maker offer, or again just more broadly, right? Just getting into 3D CAD for the first time and understanding the process will certainly benefit from this episode. So
Yeah,
yeah,
the
Mike,
fundamentals are the same everywhere you go. There's a lot of overlap. So hopefully this brings a lot of folks just the know-how that they need to make the thing in their head something in their hands.
Awesome. Yeah, I think you accomplished that, man. Thank you so much. Is there anything else? I want to give you a few shout outs from my end, but anything else you wanted to show, or are we all wrapped up here?
I think that's everything. We've condensed a good amount of SolidWorks Essentials into 100 minutes or so. That's not too bad.
Yeah, and even more, right? Because we don't show design guidance in that sense. It's not there as it's named here. So it's no, absolutely. So thank you so much. I want to show my screen here just to give you a couple shout outs and give you the stage, just to talk about some of the things that you're into and you're interested in here. But I just have my Chrome browser window up, just a couple tabs. We mentioned that you are on a BattleBots team, right? So Team Malice. Tell us a little bit about Team Malice, just a few words here.
It's much nicer than the name would suggest. Team Malice is just a really wonderful group of well-established combat roboticists. Our team captain, Bunny, she's unbelievable, and all the teammates are really great. And it's so it's an experience taking these tools that I use and do for work. I don't have a background in combat robotics. I was invited to the BattleBots TV show by one of my very dear friends to help turn wrenches and carry a 250-pound robot around.
Yeah.
Which are both things I'm great at.
It's good.
But the first time I was on BattleBots, the Maker's offer came out during that time.
Oh, cool.
Yeah, and I started getting folks on the set hooked up to it, and it's a great team. If you can find people that share even one passion with you or one interest with you, it's a wonderful time, and I just cannot gush enough over how lovely our team and leadership is.
Very cool. And that's you right here, right?
Yeah, I'm in suspenders. I'm always virtually in suspenders.
Always virtually in suspenders. So
yeah.
Teammalice.com. You guys can check that out. We have that in the chat there. And then, of course, Go Engineer, right? You mentioned you're an application engineer.
Yeah.
So yeah, tell us a little bit about Go Engineer.
Sure. So something that is a source of confusion, I think, for a lot of people is how to get SolidWorks in the first place. Prior to the Maker's offer, we had that. SolidWorks uses a reseller model, so that means that there is somebody near to you who doesn't just sell you SolidWorks, but also gets you the training and helps you figure out that what exactly you need. Do you need like the Lamborghini, full license to everything, or can you save a bunch of money and not do the whole nine? But I'm a SolidWorks application engineer. I help customers figure out what version of SolidWorks is right for them, and I have a specialization in CAM, CNC manufacturing. So if you like to turn big pieces of metal into small pieces of metal, then I'm your man.
Awesome. Well, once again, you can go to goengineer.com. You can go to teammalice.com. It's been a great year for live. I've met so many BattleBots teams this year. It's just been so cool for so many different reasons. But yeah, guys, all of you watching, thanks for hanging with us. I hope you got a lot out of this episode. I know I did. We will be back in 2023 with more live streaming. Live design is not going anywhere. We're only going to make it bigger and better. We'll be back in January with the next episode of Live. And then, of course, we have 3D Experience World here in February. So I hope to see a lot of you in Nashville. But if you can't make it that time of year to Nashville, Tennessee, hope to see you online. Just as a reminder, it is a hybrid event, so you can go in person, you can attend virtually. We'll be doing 3 full days of live at 3D Experience World, so you can hang with us there. But I hope you take in some great technical content like what you got today from Mike. But once again, thank you all for tuning in. Thank you, Mike, for hanging out with us. And
Thanks so much for having me.
Absolutely. We'll see y'all shortly.